Friends, welcome to the tutorial series on network analysis made simple. This is a VTU network analysis module-wise paper solution series. In this tutorial, we are going to solve module 5 on two-port networks of June-July 2018 paper. Friends, I prefer to emphasize on basic circuit concepts, strategy and thinking process rather than the detailed mathematical steps. I am sure you are already well equipped with the required mathematical skills. I hope this tutorial will ignite some of your thoughts. Let's go ahead. Friends, first let us solve question 1. In this question, we are required to find the y parameters and z parameters of the circuit shown in figure. So, first let us find y parameters. Observe the network. It contains one voltage controlled current source and one voltage controlled voltage source. Observe that V1 appears across the parallel combination of 1 ohm and 2 V2 current source. Similarly, V2 appears across 1 ohm resistance. So, the network can be considered to be a 3-junction node network. One junction node V1 and the other is V2 and a reference node as shown in figure. We know that the two equations that govern the complete behavior of the network in terms of y parameters are y11 V1 plus y12 V2 is equal to I1 and y21 V1 plus y22 V2 is equal to I2. Hence, by writing the nodal equation for node V1, we get V1 by 1 minus 2V2 plus V1 plus 2V1 minus V2 divided by 1 minus I1 is equal to 0. By solving and rearranging, we get 4V1 minus 3V2 is equal to I1. Now, observe equation 1 and equation 3, they are analogous to each other. Hence, by comparing the coefficients of V1 and V2, we get Y11 is equal to 4 mho and Y12 is equal to minus 3 mho. Next, to find the other two parameters, Y21 and Y22, consider the circuit shown in figure. By writing the Kirchhoff's nodal equation for node V2, we get V2 minus 2V1 minus V1 divided by 1 plus V2 by 1 minus I2 is equal to 0. By simplifying, we get minus 3V1 plus 2V2 is equal to I2. Observe that equation 4 and equation 2 are analogous to each other. Hence, by comparing the coefficients of V1 and V2, we get Y21 is equal to minus 3 mho and Y22 is equal to 2 mho. We already have found out Y11 and Y12. So, the Y parameters found are indicated here. Hope it is clear to you. Friends, to find Z parameters, consider the given network shown in figure. Friends, this time I will introduce to you different and easy procedure. Let's first convert the voltage controlled current source which is in parallel with 1 ohm into voltage controlled voltage source. By converting it, we get 2 V2 amperes into 1 ohm equal to 2V2 volts in series with 1 ohm as shown in figure. We know Z11 is equal to V1 upon I1 when I2 is equal to 0 and Z21 is equal to V2 divided by I1 when I2 is equal to 0. So, by forcing I2 is equal to 0, current flowing through this branch will be same. Let this current be I3 and let I3 is equal to 1 ampere. Then V2 is equal to 1 into 1 equal to 1 volt and V1 is equal to V2 minus 2 V1 plus 1 into 1. So 3 V1 is equal to V2 plus 1 and that is equal to 2. Hence V1 is equal to 2 divided by 3 volts. Further, let I4 be the current flowing through 2V2 volts in series with 1 ohm. Then I4 is equal to V1 minus 2V2 divided by 1 and that is equal to 2 divided by 3 minus 2 into 1 and hence I4 is equal to minus 4 divided by 3 amperes. So I1 is equal to I3 plus I4 and that is equal to 1 minus 4 by 3 and hence I1 is equal to minus 1 divided by 3 amperes. Hence, Z11 is equal to V1 divided by I1 when I2 is equal to 0. So, by substituting the values, we get Z11 is equal to minus 2 ohm. Similarly, Z21 is equal to V2 divided by I1 when I2 is equal to 0. By substituting the values, we get Z21 is equal to minus 3 ohm. Friends, next to find Z12 and Z22, consider the circuit shown in figure. We know that Z12 is equal to V1 upon I2 when I1 is equal to 0 and Z22 is equal to V2 upon I2 when I1 is equal to 0. So, let us force I1 is equal to 0 and let I3 is equal to 1 ampere. But I4 is equal to V2 divided by 1 and hence I4 is equal to V2 amperes. Now, by writing the Kirchhoff's voltage equation for this branch, we get V2 minus 2V1 minus 2V2 minus 1 plus 1 equal to 2 ohm into 1 ampere is equal to 0. By simplifying, we get minus 2V1 minus V2 is equal to 2. Now, we find that V1 and V2 both are to be found out. So, by writing another Kirchhoff's voltage equation for this branch, we get V1 minus 2V2 minus 1 ohm into 1 ampere is equal to 0. By simplifying, we get V1 minus 2V2 is equal to 1. Now, by solving the two simultaneous equations 3 and equation 4, we get V1 is equal to minus 0.6 volts and V2 is equal to minus 0.8 volts. But we know Z12 is equal to V1 divided by I2 when I1 is equal to 0. By substituting the values and solving, we get Z12 is equal to minus 3 ohm. Similarly, Z22 is equal to V2 divided by I2 when I1 is equal to 0. By substituting the values and solving, we get Z22 is equal to minus 4 ohm. We have already found out Z11 and Z21. So, Z parameters obtained are indicated here. Friends, Next, we shall answer question 2. In this question, we are required to express ABCD parameters in terms of Y parameters and H parameters. First, let us find ABCD parameters in terms of Y parameters. We know that V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. Also, Y11 V1 plus Y12 V2 is equal to I1 and Y21 V1 plus Y22 V2 is equal to I2. The strategy will be to use equation 3 and equation 4 and obtain the relations for A, B, C and D parameters. So, from equation 1 and equation 2, we have A is equal to V1 divided by V2 when I2 is equal to 0 and C is equal to I1 divided by V2 when I2 is equal to 0. So, forcing I2 is equal to 0 in equation 4, we get Y21 V1 plus Y22 V2 is equal to 0, from which we get V1 is equal to minus Y22 divided by Y21 into V2. Hence, A is equal to minus Y22 divided by Y21. To find C parameter, consider equation 3. By dividing throughout by V2, we get I1 by V2 is equal to Y12 plus Y11 divided by V2 into V1. Friends, by substituting for V1 and solving, we get C is equal to minus delta Y divided by Y21. To express B and D parameters, we know minus B is equal to V1 divided by I2 when V2 is equal to 0 and minus D is equal to I1 divided by I2 when V2 is equal to 0. So, by forcing V2 is equal to 0 in equation 3 and in equation 4, we get Y11 V1 is equal to I1 and Y21 V1 is equal to I2. Hence, minus D is equal to Y11 V1 divided by Y21 V1 and hence D is equal to minus Y11 divided by Y21. Similarly, minus B is equal to 1 upon Y21 and B is equal to minus 1 upon Y21. The ABCD parameters so obtained are indicated here. Hope you understood it. Friends, to express ABCD parameters in terms of H parameters, we know that H11 I1 plus H12 V2 is equal to V1 and H21 I1 plus H22 V2 is equal to I2. Observe that equation 1 contains terminal quantities V1, V2 and I2 and equation 3 contains I1, V2 and V1. So, using equation 4, current I1 in equation 3 is to be eliminated. So, from equation 4, we get I1 is equal to 1 divided by S21 into I2 minus H22 divided by S21 into V2. By substituting for I1 in equation 3, solving and rearranging, we get V1 is equal to minus delta H divided by H21 into V2 plus H11 divided by H21 into I2. Observe that equation 1 and equation 5 are analogous to each other. So, By comparing the coefficients of V2 and I2, we get A is equal to minus delta H divided by S21 and B is equal to minus H11 divided by H21. To find C and D parameters, observe equation 2 and equation 4. Both equations contain the same terminal quantities I1, V2 and I2. Hence, equation 4 is just rearranged such that it is analogous to equation 2. Now, by comparing the coefficients of V2 and I2, we get C is equal to minus S22 divided by S21 and D is equal to minus 1 upon S21. Friends, the ABCD parameters in terms of H parameters obtained are indicated here. Note that in this question, we have used different approaches to make the solution simple. Hope you appreciate it. Friends, next we shall solve question 3. In this question, we are required to determine Z parameters for the network shown in figure. Before adopting the procedure to find Z parameters, if it is possible to reduce the network to make the solution simple, we have to do it. Observe the network. Hope you identify one star consisting of 1 ohm, 2 ohm and 5 ohm and another delta consisting of 1 ohm, 2 ohm and 3 ohm. Of these two networks, any one network can be converted. So, I prefer to choose delta network of 1 ohm, 2 ohm and 3 ohm to convert it into equivalent star. Let R1, R2 and R3 be the star connected resistances as shown in figure. We know that R1 is equal to 1 into 3 divided by 1 plus 2 plus 3 and hence R1 is equal to 1 divided by 2 ohm. Similarly, R2 is equal to 1 into 2 divided by 6 and hence R2 is equal to 1 divided by 3 ohm. And R3 is equal to 3 into 2 divided by 6 and hence R3 is equal to 1 ohm. By replacing the delta into equivalent star, we get the network shown in figure. Friends, 1 by 3 ohm and 5 ohm are in series and their equivalent is 16 divided by 3 ohm as shown in figure. Now, you find that the network has transformed into a simple two-loop network. We also know that the two equations which describe the behavior of the two-port network in terms of Z parameters are Z11 I1 plus Z12 I2 is equal to V1 and Z21 I1 plus Z22 I2 is equal to V2. Observe the network. Current through 16 divided by 3 ohm is I1 plus I2. To find Z11 and Z12, by writing the Kirchhoff's voltage equation for the input loop, we get 16 divided by 3 into I1 plus I2 plus 1 divided by 2 into I1 minus V1 is equal to 0. By solving and rearranging, we get 35 divided by 6 into I1 plus 16 divided by 3 into I2 is equal to V1. Observe that equation 3 and equation 1 are analogous to each other. So, by comparing the coefficients of I1 and I2, we get Z11 is equal to 35 divided by 6 ohm and Z12 is equal to 16 divided by 3 ohm. Next, to find Z21 and Z22, By writing the Kirchhoff's voltage equation for the output loop, we get 16 divided by 3 into I1 plus I2 plus 1 into I2 minus V2 is equal to 0. By solving and rearranging, we get 16 divided by 3 into I1 plus 19 divided by 3 into I2 is equal to V2. Observe that equation 2 and equation 4 are analogous to each other. So, by comparing the coefficients of I1 and I2, we get Z21 is equal to 16 divided by 3 ohm and Z22 is equal to 19 divided by 3 ohm. Hope it is clear to you. Friends, finally, we shall answer question 4. In this question, we are required to express H parameters in terms of Y parameters, meaning we know Y parameters and we have to find the relation for H11, H12, H21 and H22 in terms of Y parameters. Let me adopt a different approach this time. From H parameter equations, we know that H11 is equal to V1 divided by I1 when V2 is equal to 0 and H21 is equal to I2 divided by I1 when V2 is equal to 0. We also know Y11 V1 plus Y12 V2 is equal to I1 and Y21 V1 plus Y22 V2 is equal to I2. By forcing V2 is equal to 0 in equation 3 and in equation 4, we get Y11 V1 is equal to I1 and Y21 V1 is equal to I2. Using equation 5, we get H11 is equal to 1 upon Y11. Similarly, using equation 5 and 6, we get S21 is equal to Y21 divided by Y11. Very simple, isn't it? Next, to find H12 and S22 from equation 1 and equation 2, we have H12 is equal to V1 divided by V2 when I1 is equal to 0 and S22 is equal to I2 divided by V2 when I1 is equal to 0. So, forcing I1 is equal to 0 in equation 3, we get Y11 V1 plus Y12 V2 is equal to 0 or Y11 V1 is equal to minus Y12 into V2, from which we get V1 is equal to minus Y12 divided by Y11 into V2 and H12 is equal to minus Y12 divided by Y11. Now, to find H22, we know that equation 4 is the output equation. So, using equation 4, we have to find the ratio of I2 divided by V2 when I1 is equal to 0. Also, we have already found out V1 when I1 is equal to 0 and that is equation 7. Hence, substituting for V1 in equation 4, we get Y21 into bracket minus Y12 divided by Y11 into V2 plus Y22 V2 is equal to I2. By solving and rearranging, we get S22 is equal to delta Y divided by Y11. Friends, do you feel that this procedure is quite simple? Friends, to strengthen your basic circuit concepts and develop your thinking process, I suggest you go through my textbooks, Network Analysis Made Easy, Basic Electrical Engineering, Basic Electronics, and Linear Integrated Circuits and Applications. You also can refer my CET handbook on electrical and electronics engineering for preparing for your competitive examinations. Friends, all books are available online. Thank you for watching this video.